let's take a look at another brand new product. This time it's the CleanPower for the Sega Saturn. This is the prototype I've just had. If you're unaware, I've already made the Dreamcast CleanPower. This allows you to power the Dreamcast from USB-C. We've made it for the Master System 1 and 2, the Mega Drive 1 and 2. So the benefits of this is instead of having a big, bulky and old power supply that generates a lot of heat, you can accidentally blow these up if you buy, say, a Japanese console and plug it in the UK, as well as many other issues such as unstable power rails. The Sega Saturn CleanPower allows you to simply plug in a USB-C cable and power any version of the Sega Saturn from a single cable. So let's take a look if this prototype has worked. So what we need to do is get a working Sega Saturn. And this one I've already stripped down ready for this and tested that the console works. We're going to leave the disk drive in and I'll do further testing on ODEs as well to make sure it fully works. And this board's quite simple. So what we have up top is the power plug plugs in here, or in the VA0 version the power plug plugs here. The USB board, which is identical to the Dreamcast CleanPower board, plugs in here to offer you the USB power. We have a bunch of LEDs and fuses indicating where the power's good and everything's protected for overloads and overheats and all the good stuff. We've got a little test pad here. If you don't want to plug in the power switch, you can just short these with tweezers or permanently keep it on by solving them together. Then we have the output rails here and here based on version, as well as you'll notice the 3 volt and 5 volt rails and the 12 volt and 9 volt rails here and here are switchable, which you have to set these two switches up correctly for which version of console you have, because some output 9 volts, some output 12, some want double 5 volts, some want 3 and 5 volts. So we'll go through all that when the product releases. Now, as I mentioned, this is a prototype, and usually I simply buy these and assemble them. But in this case, this video is actually sponsored by PCBWay, so they have made this entire PCB for me. This is the first time I've used them, and it's been a really good experience. And if you guys want to get PCBs made, you can obviously just visit PCBWay.com. If you want just a bare PCB, so just a circuit board without all the components on, then you simply select PCB prototype, enter the width and height of your PCB, the number that you want, the number of layers and thickness, and start a quote. In the case of this board, this is actually quite a special board. This is a 3-ounce copper to dissipate all the heat, so nice thick copper traces, some big large components, and quite an expensive board overall to produce. If you want to get fully assembled, you simply click PCB assembly, enter the same thing. You'll have to enter this time the number of pads, the number of holes, a bit more information as well as uploading the bill of materials. But the team at PCBWay immediately email you within usually less than an hour and talk you through the process if they need any more details. As well as the bare circuit boards and the fully built circuit boards, you can obviously get as well the flexible circuit boards such as these, where they're obviously flexible, unlike a polyamide backing. That would be the FPGA rigid option. And then you can also have CNC and 3D prints, which I've also had in the past I've simply paid for. So for example, these really high quality brackets, they are SLA printed or resin printed in essence to be really highly accurate. So if you want to get these made in low volume as you're releasing your first products, you can also get 3D printing. So I couldn't recommend these guys enough. The entire process of ordering this fairly complicated circuit board for the first one was really easy and straightforward, and they communicated the whole way. And then on top of that, I have a bunch more that I can send now to testers to verify the functionality of this board once we've done this test. So thanks again to PCBWay for sponsoring this video, and I'll definitely be using you guys in the future. So on to getting this in the board and actually testing it. We can connect it to the console, but before we do that, we need to make sure this board actually works. So as I mentioned, let's just grab the USB-C board that will come with the final product and connect power into the board. Now we have the USB-C power coming in, which verifies we've got power. The power good light shouldn't be on. It's kind of half on, not fully, as you see. That should come on when we turn the power on with a switch, which we haven't yet. Power in's okay. So USB is the power coming in through the USB cable, goes through the fuse, then goes to effectively the regulator here, which means it's got power, but the enable pin to turn this on is not currently enabled with the switch. So we have a slight bug on the LED, which is no biggie. We don't really need to make a new board just to fix an LED problem. That should turn out to be probably simple. So with that on, let's try and turn on with the Saturn power switch. You can see now we've got power on, come on, and power good's gone off. So I think I've just got this LED inverted, which is likely the case. The switches are currently set up to 9 volts. Let's just take that off so you can see clearer. So you can see that one's set to 9 volts, that one's set to 5 volts at the minute. We'll pull out my new little favourite multimeter, just because it's so cool. It's tiny, super cheap, and you can fit it on camera nice and easy. So this is a cool little multimeter we started stocking recently. Let's just measure the voltages. We'll go on ground here, and the 3/5 volt. I believe it should be 5 volts, which there you can see it is 5 volts. Go to the other one, could be 5 volts, it is. And the 12/9, I think we had set to 9, and we do exactly 9. So it looks like we've got good power rails, so this is safe to plug in to the Saturn. So far so good. Bring the Saturn back in, and then we will have these pins here. The important thing here, and it is important, some have 5 pins, some have 4 pins. Let me just show you. Let's disconnect everything and show you this first. So this is a model here, which if we look at the original power supply, tells us on the back, on the silk screen, that this is a 5 volt, 5 volt, 12 volt model. So this is 2 5 volts and a 12 volt. So we'd have to set this one up as 5, 5 and 12. We currently have it set at 5, 5, 9. But I do believe the ones that are 12 volt work at 9 volt anyway. We can prove that and test that when we come to it. But the important thing I was mentioning, you see how there's 6 pins on here? Some only have 5, some only have 4. Whenever you're installing this board, always make sure you start with the bottom, touching the bottom pin, so the extra pins are up top. If you install it lower down, what you're going to do is bring down the 12 volt onto the 5 volt, the 5 volt onto the ground. You're going to short this board, you're going to blow this console. So there's a big warning, which I'll probably put on here, a big arrow here, and a big yellow warning or something. You want to make sure you're installing it so the bottom pin is on the bottom pad, like so. Do that without power first and confirm before you turn on. So the biggest challenge in making this board was making sure it fits every single version of console, and there's 14 versions. In fact, I think there's 16, but I've only got 14 of the versions. And you can see here, every single one I've had to measure with a vernier and make sure that this board fits on every single board. We have here the Type C, the latest versions. You can see this only has 4 pins. Same principle. Install there. And if you're wondering what power settings to set them to, you'll see that on the board, I've written as much notes as I can. So typically VA6 to 14, which is this one we just looked at, is 5 volts, which it is. VA0 to 5 is 3 volts. VA6 plus PAL is 12 volts, and VA0 to 14 is 9 volts. And again, if you're unsure what it is, just use your old power supply if you have it. Look at the rating written on. The old power boards, they almost always have it written on. And you can see there, it says DC 5 volt, DC 5 volt. And there's only 4 pins. So this is ground, ground, 5, 5. And there is no 9 or 12 volt. And if you're still unsure, jump on discord.gg/RetroSix. And this is the oldest model, the VA0. And this one is quite different. So you'll see that it has a power ribbon coming off that connects to the motherboard like this. And the power switch, which I don't believe I've even got here. It's missing out of this one somewhere. But the power switch is from here to the board here. So that's your power switch. You'll notice, however, on the CleanPower, we have the switch here, and the middle pin will be missing on production, just like this. So for the VA0 model, you would connect the power switch here instead of here. And in order to connect the board, the production will come with this cable. So this connects to the board, and then connects up to this power output here. And then I'm going to get this board to come with a block that sits on the bottom of here. Slightly proud of this, with double-sided tape on. So you can optionally stick it on here and stick this board anywhere you like here free. So that's how we'll mount it in the VA0s. And that's every model version really. So now we know it fits, let's just get it installed in this one and do some testing. We need to set it to 5, 5 and 12, like so. Connect it up to the console at the bottom pin, push in. You can see that's quite close there. I did measure it with a vernier, and it does fit. But I'll probably nudge it slightly over this way, just a mil, just so it's not right on the edge of the board. We'll connect the power on switch here. We'll make sure we're turned off. And then we will get the USB-C board. And again, when this is in production and we've tested this all works, you'll get a black and white bracket that sits in here perfectly, obviously specific to the Sega Saturns, and you'll have it nicely there. That will be mounted to the chassis. So we plug in there. Let's get an AV lead so we can see the output. Let's bring up the monitor, and I think that's on, that's set up, plugged in. Yeah, I think we're ready to go. So let's see if this works. And there we go, nice. And you can also see there, when you use high quality USB power supplies, you get a really clean video output. With the Dreamcast, we've had a ton of people mention how much cleaner the video becomes, because obviously this is hence the name, CleanPower. It's a really stable voltage rail. We're going to have to use the Wild Things controller. You never know when you're going to need them turbo buttons. Let's just set this up as English. And of course it's 1994, so we'll leave that date correct. And now I think it's time for a bit of Duke Nukem. I'll just hold the switch down here. The other benefit now of the CleanPower is you're not going to accidentally zap your hand with 240 volts like I've done many, many times repairing these consoles. And you can see now, start application, because we obviously started this without a disc in. If you just turn the console on and off, it would auto boot the game for you. And there we have Duke Nukem. And now what we need to do, there's more than just simply turning this on and going, oh look, it works in a console. This is the stuff that you guys don't normally see. Which is, once the product is made like this, yes, it's working, yes, it's showing on screen. But I've got no idea of the thermals at the moment of this. I've got no idea of how stable these power rails are. So let me just show you guys how I test and verify that these products are actually good and not just the turn on but the really unclean power, for example. So the first thing I'd do on this normally is check thermals before anything else. Now it's only been running a few minutes, but let's just quickly do thermal check. You can see the hottest part on the board is 31 degrees, which means my hand is hotter than this board. So, for example, there's my hand in, and it becomes the hottest object in this scene. So that means that this board, rightly so, is stone cold, which is awesome, because the Dreamcast, the first version that we made, you can see the differences in when I make new versions and figure things out. This is running at literally less than 30 degrees, and this thing will run within range, which is about 60 degrees. So I plan to put this new design, and these are all synchronized regulators, so they all fire in sequence, one after the other, as opposed to 3 independent regulators like this. So we have improvements coming to the Dreamcast CleanPower as well. So thermal's looking good, which is great. We'll come back and test that after this is run for 20 minutes plus. Next up, we want to check how good the voltage rails are. So for that, we want to solder a ground. So I'm just going to turn off the power a minute. I'm actually going to unplug the power, because even with the power switch off, there is power going to the circuit. It's just simply turned off, disabled. So if you're going to work on this, fully unplug the USB. And you'll notice with this board being 3-ounce copper, soldering iron takes forever to warm up the solder. And I mean forever. Which is a good thing. The entire board is super thermally conductive, so all the heat has been absorbed into the board, which is by design. Now let's clip on the oscilloscope. Let's get this thing back up and running. Let's get the scope set up to do some readings. So we'll leave it at the 10 volt. The 12 volt will be slightly over, but let's just do some, in fact, yeah, let's chuck it to 20 volt at the minute. Let's just do some voltage readings first to verify. The time at 1 millisecond is actually okay for this, because we're doing power readings, not signals. Turn the trigger off. Let's take a look at the USB in. And we can see that's 15 volts. Let's chuck some measurements on here, and they can see them there. So we know we have USB input. We also should see that these voltages are nothing, because they're not turned on, which is correct. Turn them on, and we know this works. I'm just verifying with the multimeter. We know we've got voltage rails, but we want to make sure the meter reads them fine. This reads 5.34 on the maximum, but that's including all the tiny little spikes and peaks. And the 12 volts reading 12.4. So oscilloscopes always read slightly above the voltages because they're not root mean square averaged. They're accounting for the absolute peaks, which are even minuscule, tiny amounts of time. So this is now the console up and running and turned on. So you can see in the background there we have the console running. So under load, this is under full load. So to measure for noise, similar to you've seen how I tested the GBO CleanPower, even though I was using a differential probe then for super accurate results, this regular probe should be okay. Change it to AC coupling, bring down to probably 500 millivolts, and let's probe the 5-volt rail. And you can see what looks like, if we zoom out, a lot of noise. That looks like quite a significant amount of noise here. But this is the importance of knowing how to actually measure things. So that looks like 240, so a quarter of a volt noise, which is terrible. So let me show you why that isn't the case. See this ground lead here? We have a massive loop here of ground. All that noise is going to be coming off this ground loop. So when you use the differential probes and you probe things accurately and correctly, you'll learn these things, and that isn't just simply, oh, there's some noise on the system. So see the noise there? All we're going to do, disconnect this probe. Let's just watch how much this is reduced by removing that wire from the loop. And now look at the difference there. That ground clip that was 240, we go out in time. You can see now the rail is 30 millivolts ripple. And the only difference is here, I'm just simply holding on the ground probe straight next to the 5-volt rail. So you can see the importance of testing correctly. So let's go ahead now and test the 12-volt rail in the same way. I'm just going to grip on here and probe on here at the same time. And we can see the 12-volt rail, we pause that, has a ripple of 50 millivolts. So the 3-volt rail's got a ripple of 30, and the 12-volt rail has got a ripple of 50. And the 5-volt rail similar. It's the same regulator, you just switch between the voltages. So we have nice, clean power there. And if we now go back to, say, DC view, the way we'd look at it, and go back up to see the full 12 volts, you'd see how smooth that looks. We go to the 5-volt rail and lower down the voltage to fit it on. You'll see that looks nice and smooth. And this is really fast as well, you can slow it down. So you've got a nice smooth voltage rail there. So that's how you test that your rails are nice and smooth. Let's see if we can find out which rail this CD is running off as well. So we probe on the 5-volt rail and start the spin. The problem is going to be because the voltage rails are so smooth, we might not see it. So I can't see any movement there. Let's try the 9-volt rail. No, and it's not going to even make a slight bit of difference because they're so well regulated. Normally, this pulling some load, you might see some ripple on the line, but because these are so well regulated, you're not seeing anything. So one last test. Let's compare this to the original power supply. So now this is live. Let's make sure we do nowhere near this area here. We're going to get zapped. I'm going to go on the ground probe and on the 5-volt rail. So let's take a look at this. We have 140 millivolts, which isn't terrible. It's not great, but it's not terrible. Let's spin the disk, and you can see the disk under load is generating spikes. So if we zoom out to see that better, this is what I was trying to see on ours, but it just didn't do it. So if I spin the disk now, you can see when the disk loads up, it causes a bit more ripple, which is the regulator struggling to keep up. So it's not a huge amount, but it shouldn't be pulsing like that. Go to the 12-volt rail, and you can see a very similar story. I'll spin the disk, and the disk also affects the 12-volt rail quite a lot. So let's zoom out, and let's slow this right down so we can see the actual voltage coming in. And you can see as the disk spins, wow, that is absolutely huge actually. So that 12-volt rail is really struggling. I didn't expect it to be that bad. So that's the 12-volt rail with the regulator with very distinctive spikes of half a volt pretty much, and you can go even higher if you wanted to go to some of these peaks up here. So you're talking a good half a volt of ripple on the old power supply. But you can see either way, the old regulator works, but isn't the cleanest. And the CleanPower gets 30 to 50 millivolts, stays super cool, and is universal worldwide. So short of fixing the bug with the LED being inverted I don't think there's any problems with this board at all. It's ready to go to production. So I'll chuck this into manufacturing now. I'll leave this running for 24 hours and do thermals while it's in a case, but I can't suspect this increasing thermal. It's already at 30 degrees, which is air temperature practically. So I can't imagine this getting too hot, but I'll still do all the tests, get this into production, and you should see this released in 3 to 4 weeks. So I hope you guys enjoyed learning a little bit about how I test and confirm the functionality of our products before we sell them. And if you have any questions or are just generally interested in repairing consoles, don't forget to jump on our Discord, discord.gg/RetroSix. That's it for this one, guys, and I'll catch you in the next.